Here is our a. It's 5. This is the same. X times x minus 2 is the same as saying x minus 0 times x minus 2. So, here it is. 5 times x minus 0, which is the same as saying x, times x minus 2. Negative r is 0, so r is 0. Negative s is negative 2, so positive s must be positive 2. We'll continue on with equations of a parabola in factored form. We can determine or approximate the x-intercepts, otherwise known as zeros, and the axis of symmetry of the parabola given its graph. Here's an example. Y equals x plus 3 times x minus 3. This is what the parabola of x plus 3, x minus 3 looks like. The zeros. We can locate them here on the graph where they cross the x-axis. We have negative 3, 0 and 3, comma 0. The axis of symmetry, then, is the midpoint between these 2 points, which in this case happens to be the y-axis, or x equals 0. The vertex occurs at 0, comma, negative 9, where x is 0 and y is negative 9. Let's look at another example. Y equals 0.2 times x plus 5 times x minus 1. Here's the parabola. Take a moment now and identify the zeros and the axis of symmetry. Also take note of the vertex. Let's start by identifying the zeros. Here's the first one at negative 5, 0. The second is located here at 1, comma 0. The axis of symmetry is between these 2 points. At x equals negative 2. Our vertex is actually located at negative 2, comma, negative 1.8. Let's look at example 3. Y equals 2 times x plus 1 times x minus 3. Here's what the parabola looks like for this quadratic expression. Identify now the zeros and the axis of symmetry. The zeros are located at negative 1, 0, and at 3, 0. This means that the axis of symmetry occurs between these two, at x equals 1. Our vertex, as we can see here, is at 1, comma, negative 8. Let's make some observations about the examples we just looked at. Let's first notice, in the first example, x plus 3 and x minus 3. This is our x minus r, x minus s. If this is minus r, then r is negative 3. And negative 3 is one of the x-intercepts, or one of the zeros. If minus s is negative 3, then s is positive 3, which gives us, this gives us our other x-intercept. The same can be said here. Our r is negative 5, and so is our first x-intercept. Our s is positive 1, our other x-intercept. The same will work out for example 3. Our r is negative 1, which is our first x-intercept, and our s is positive 3, which is our other x-intercept, or 0. So the x-intercepts have the same numbers, but opposite signs to the numbers inside the brackets in factored form. So, it's the opposite of this. Our x-intercept is not at positive 5, but at negative 5. The other one is not at negative 1, but at positive 1, the opposite sign to what's in the brackets. We also can calculate the axis of symmetry by adding the two x values from the coordinates of the zeros and dividing by 2. It works out every time. The axis of symmetry is located in the middle of the two x-intercepts. And the way that you can find it is by adding the two x-intercept x coordinates together and dividing by 2. Our vertex is at 0, negative 9. In this one it was negative 2, negative 1.8. And for the third example, it was at 1, negative 8. The x-coordinate of the vertex has the same value as the axis of symmetry. Notice, negative 2, negative 2, 0, and 0. The axis of symmetry here was x equals 1, which is the x-coordinate in the vertex. Therefore, the x-coordinate of the vertex can be calculated as the midpoint between the intercepts. So, the vertex, x-coordinate, is equal to the x-intercept 1 plus x-intercept 2 divided by 2. Let's try an example. Determine the vertex coordinates of the quadratic relation y equals x minus 2 times x minus 6.